So this video is to go over Test 5 test review. So in number 1 it says list the first 5 terms of each sequence. So let's take a look at A. So in A they give you A sub 1 equals 7. So A sub 1 is your first term. And they give you the formula A sub n plus 1 equals A sub n minus 6. So they give you the recursive formula. So when you're dealing with a recursive formula, you need to know the previous term in order to find the next term. So they want you to find the first 5 terms of the sequence. So we're already given that A sub 1 is 7. So A sub 1 equals 7. They give us the recursive formula, so A sub 2 is going to equal A sub 1 minus 6, so 7 minus 6, and that gives us negative 1. No, positive 1, my bad. So that gives us positive 1. A sub 3 is going to equal A sub 2 minus 6. So 1 minus 6, and that gives us negative 5. A sub 4 is going to equal A sub 3 minus 6. So A sub 4 equals negative 5 minus 6. Negative 5 minus 6 is negative 11. And the fifth term, so A sub 5 is going to equal A sub 4 minus 6. So negative 11 minus 6, and that gives us negative 17. So the first 5 terms of the sequence are 7, 1, negative 5, negative 11, and negative 17. So you only have to go to the 5th term. If you put 6 terms, you're going to get points counted off because it says 5 terms. So they give you the first term, so you just have to find the next 4. That's all you have to do. Alright, so let's take a look at B then. So A was an arithmetic sequence. B is a geometric sequence because we have a common ratio and the exponent n minus 1. Alright, so when we're given the explicit formula for a geometric sequence, the first term, so A sub 1 is going to be negative 3. So A sub 1 equals negative 3. Your R value is always the number that's being raised to the power. So negative 1/3 is being raised to the n minus 1 power. So negative 1/3 is your R value. So in order to find the second term, we are going to do negative 3 times negative 1 over 3 to the 2 minus 1 power. So 2 minus 1 is just 1, so it's going to be negative 3 times negative 1/3, and that gives you positive 1. So then the third term is going to be negative 3 times negative 1/3 to the 3 minus 1 power. So in other words, it's going to be negative 3 times negative 1/3 squared. So that's going to give us negative 1/3. A sub 4 equals negative 3 times negative 1/3 to the 4 minus 1 power. 4 minus 1 is 3, so it's negative 3 times negative 1/3 to the 3rd power. And that's going to give us positive 1/9. The fifth term is going to be negative 3 times negative 1/3 to the 5 minus 1 power, or fourth power. And that is going to give us negative 1/27. So the first 5 terms of this sequence would be negative 3, positive 1, negative 1/3, positive 1/9, and negative 1/27. So first 5 terms, 1, 2, 3, 4, 5. If you put any more than 5, you'll have points counted off because it just asks for 5. Alright, so we're going to move on to question number 2. Question number 2 says, for 2A, find the 55th term given the sequence. So if we look at 2A, we're given an explicit formula because it says A sub n equals. That's always explicit. Explicit starts with A sub n. A sub n equals negative 25 minus 1/4 n. Alright, so this is an arithmetic sequence. We know this because no numbers are being raised to a power. So all we're going to do, since this is the explicit formula, we're just going to substitute 55n for n. So A sub 55 is going to equal negative 25 minus 1/4 times 55. So then that's going to give us negative 155 over 4. And we can double check in the calculator. Alrighty, so negative 25 minus 1/4 times 55. So that gives us negative 38.75. We're going to change that to a fraction because we're given fractions, which is negative 155 over 4. So we're good. So anytime we're given fractions or whole numbers, we want to make sure that we state our answer as a fraction if it is a fraction. If they give us decimals, then it's okay for us to leave our answer as a decimal. Alright, so let's look at B. So B says find the 7th term. And we're given an explicit formula again. It's A sub n equals. But this time we have 5 times 1/4 to the n minus 1 power. So this is a geometric sequence. Alright, so but still we're going to be substituting 7 for n because we want to find the 7th term. An explicit formula tells us any term in a sequence. Alright, so A sub 7 is going to equal 5 times 1/4 to the 7 minus 1 power. So when we type this in the calculator, we should get 5 over 4096. So the 7th term of the geometric sequence would be 5 4096. Alrighty, so let's take a look at number 3. Alright, so for number 3 it says find the 22nd term, and they give you the 12th term and the R value. So we're given the 12th term, so we'll have to think, okay, so how many more times would I have to multiply by R to get to the 22nd term? So 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So we're going to have to go 10 more times, or multiply by R 10 more times to get to the 22nd term. So a sub 22 is going to equal 12, your 12th term, times 2/3, your r value, and 2/3 is going to be raised to the 10th power because 22 is 10 more terms beyond the 12th term. So then we type this in the calculator. So 12 times 2/3 to the 10th power. And we're going to get 0.208098359. So let's try to change that into a fraction. Our calculator won't do it, so we'll have to do it ourselves. So when you raise a fraction to a power, you raise the numerator to the power and the denominator to the power. So this is the same thing as 12 times 2 to the 10th over 3 to the 10th. So 2 to the 10th is 1024. 3 to the 10th is 59,049. So then this is the same thing as 12 over 1. So 12, when we're multiplying fractions, we multiply numerator to numerator, denominator to denominator. So 12 times 1024 gives us 12,288 over 59,049. Alright, so now we have to remember our rules of divisibility. So if we add up the digits in the numerator, we'll get 8 plus 8 is 16, plus 2 is 18, plus 2 is 20, plus 1 is 21. So we know the numerator is divisible by 3 because 21 is divisible by 3. So let's check to see if the denominator is divisible by 3. So 9 plus 4 is 13. 13 plus 9 is 22. 22 plus 5 is 27. And 27 is also divisible by 3. So that we know that we can reduce this fraction by a factor of 3. So 12,288 divided by 3 is 4,096. 59,049 divided by 3 is 19,683. So this will be our 22nd term of the sequence. Alright, so I'm going to go ahead and cut this video short at this time. If I could find where the thingy thing is.